Have you ever built a code editor or compiler that checks for matching brackets? That's the heart of LeetCode's valid parentheses, a pattern mastery 100 classic and one of the most asked interview questions at Google and Amazon. Over 25% of candidates trip on subtle edge cases. Let's make sure you're ready for any bracket puzzle. Let's tackle this using the basic method, so you'll be able to break down, structure, and explain your logic fluently. Given a string containing just comma, determine if the input is valid. A string is valid if open brackets are closed by the same type. Open brackets are closed in the correct order. For example, are valid, while, are not. Edge cases, empty strings, single characters, or mismatched brackets. Imagine you're building an online IDE that needs to instantly alert the user if their code's brackets are balanced before they hit compile. You want this logic to be fast and foolproof? A brute force solution might repeatedly search and remove pairs, but that's inefficient and hard to scale. Optimal approach. Use a stack. Every time you see an opening bracket, push it onto the stack. For every closing bracket, check if the top of the stack matches. If it does, pop. If not, or if the stack is empty, it's invalid. Time complexity. ON, space complexity. ON, in the worst case, for all opens. Here's the plan. Initialize an empty stack. Create a mapping of closing to opening brackets for quick checks. Loop through each character. If it's an opening bracket, push it onto the stack. If it's a closing bracket, check if the stack's top matches the corresponding opening. If not, return false. Pop if it matches. After processing, if the stack is empty, return true. Otherwise, return false. Let's narrate the logic. We start by defining the solution class. This is where LeetCode finds the method that solves the problem. This defines our function, isValid, which checks whether a string of parentheses is properly balanced. We create an empty list called stack. This will help us simulate the opening brackets we've seen but not yet matched. We define a dictionary that maps each closing bracket to its matching opening bracket. This acts like a quick reference guide during our check. We now loop through each character in the input string. Since we inspect every character once, this solution runs in ON time. If the character is an opening bracket, we push it onto the stack, waiting for a matching closing bracket later. If the character is not an opening bracket, it must be a closing bracket. We check two things. If the stack is empty, we have a closing bracket without anything to match, invalid. If the top of the stack does not match the expected opening bracket, the order is incorrect, also invalid. In either of those cases, we return false immediately. If the brackets match, we pop from the stack, meaning this pair is successfully matched. At the end, if the stack is empty, all brackets were properly matched. If anything remains in the stack, it means there were unmatched opening brackets. And that's how this algorithm works. It first sets up a stack and a bracket map, then walks through the string checking pairs and ensuring everything matches in the correct order. Efficient, simple, and elegant. Test case check. Let's walk through it. Let's test our function using this input. This string represents a sequence of parentheses, and our goal is to determine whether the parentheses are valid, meaning every opening bracket has a matching closing bracket in the correct order. Quick logic check. Here's why the solution works. The first character is comma, which is an opening bracket, so we push it onto our stack. The next character is comma, a closing bracket, so we check the top of the stack. The top contains comma, which correctly matches this closing bracket. Because every opening bracket found a valid closing partner, the entire string is balanced. And that's exactly what our program outputs. True. This confirms that our code is working correctly and passes the test case. So, our implementation is correct. The algorithm successfully verifies that every bracket is matched and properly ordered, efficient, accurate, and reliable. We begin by defining the solution class, the structure where LeetCode expects your method to live. This defines our function isValid, which determines whether a string of brackets is properly balanced and correctly ordered. We create an empty list called stack. Think of this as a waiting area for opening brackets that still need to be matched. We define a dictionary that maps every closing bracket to the opening bracket it expects. This gives us instant lookup when checking for valid pairs. We loop through each character in the input string. Since we process every character once, this solution runs in ON time. If the character is an opening bracket, we push it onto the stack because we'll need to match it later. Otherwise, the character must be a closing bracket, so now we check for a valid match. We perform two essential checks. If the stack is empty, we have a closing bracket with nothing to match, invalid. If the top of the stack isn't the matching opening bracket, the order is wrong, also invalid. If either check fails, we return false immediately. If the closing bracket matches the expected opening bracket, we pop the opening bracket off the stack. It's now successfully paired. At the end, we check whether the stack is empty. An empty stack means every opening bracket found a matching closing bracket. If anything is left, the string isn't fully balanced. And that's how this algorithm works. It first sets up a matching system with a stack and a bracket map, then processes each character to ensure every opening bracket is properly paired. Let's test our function using this input. This string represents a sequence of different types of brackets, parentheses, square brackets, and curly braces, and our goal is to check whether all of them are properly matched and in the correct order. Quick logic check. Here's why the solution works. The algorithm uses a stack to track opening brackets. We see push it. We see comma it correctly matches pop it. We see push it. We see comma it correctly matches pop it. We see push it. We see it correctly matches pop it. At the end of the scan, the stack is empty, meaning every bracket had a proper match. And that's exactly what our program outputs. True. This confirms that our code is working correctly and passes the test case. So, our implementation is correct. The algorithm successfully verifies all brackets are matched and properly closed, efficient, accurate, and reliable. The takeaway? When you see problems about order, pairing, or nested structures, think Stack. It's one of the most powerful tools for building logic that mirrors real-world compilers, editors, and syntax checkers. Alright, let's wrap it up. The valid parentheses problem is a simple-looking but classic test of logic and stack mastery, one that shows up constantly in interviews because it reveals how cleanly you can reason about structure and order. We started with the core goal. Check if every opening bracket in a string has a matching closing bracket of the same type, and in the correct order. It's all about maintaining balance and proper nesting. We compared approaches and saw why repeatedly removing pairs or scanning back and forth is inefficient. The optimal way is to use a stack, a perfect fit for problems that follow a last opened, first closed pattern. Our logical plan was clear. Use a stack to track opening brackets, map each closing bracket to its match, and check as we go. If something doesn't match or the stack empties too early, it's invalid. If we finish with an empty stack, it's valid. We implemented the logic step by step and ran it successfully on LeetCode. No errors, smooth execution. Every test case passed perfectly, confirming that our stack-based approach handles all types of bracket combinations, including tricky edge cases.